Let's see the second type of sets of data. Its name is very interesting. It's a matrix. What is a matrix? Two definitions. Number one, a matrix is a set of vectors. Remember what is a vector? A vector is a set of data where a single data has a single position. So a matrix is a set of vectors. Second definition is a set of data organized in rows and columns. Is the same. Okay? It is very important for you to understand the concept of set of data, vectors and matrix. When you go to the cinema, you can see the number of each single chair inside the cinema. The single chair has a letter and a number. And probably when you come to the cinema, somebody say you, hey, your seat is H12. That means you have to reach the seat in the row H and in the position 12. This is matrix? Yes, of course, this is a matrix. So remember, matrix is a set of vectors, and a vector is a set of data where a single data has a single position, and a specific position. Or a matrix is a set of data where each data is in a specific row and specific column. Set of data organized in rows and columns. Okay? Let's see an example. The statement. Build a program that allows you to load a 2 by 3 matrix and determine in which position is located the largest number stored there. So, this is the statement or objective. Now, the semantic analysis. You need to remember what is load in the terms of the computer programming world. Then, what is a 2 by 3 matrix? Determine which position. You have to remember what is a position in a matrix. Exactly what is that? And what is the largest number? What does it mean? Okay. So let's see. What is load? Load is read a set of data and store it in each box of the matrix. 2 by 3 matrix means a matrix organized with data organized in 2 rows and 3 columns. A position in a matrix is the description of the row and the column where there is a specific data, well, a specific number, and the largest number is the number of every the other numbers. Okay? Remember, if you understand this semantic analysis, you can say, I really understand the statement. If you don't understand, or it probably is for you very hard to understand this semantic analysis, probably you didn't understand the statement, and it's impossible for you to make program. Let's see the IPO analysis. First, we are going to define in general terms the general instructions of the algorithm, and then we are going to specify them. So the first part or the first step is load the matrix. Remember, this is a matrix 2 by 3. Then, in the process, what do we need? We need to determine in which position is located the largest number stored there. So we need to select the largest number of the 2 by 3 matrix. Step number 3, show the position or the positions where this largest number is located in the matrix, of course. Okay? And the output is the position or positions of the largest number of the 2 by 3 matrix. Okay, you can see it is very easy. Now we are going to specify the specific instructions of these general instructions. Load the matrix. So we are going to use a loop for R as row from the first row to the second row with a step of 1. Remember, this is a 2 by 3 matrix. That means 2 rows, 3 columns. Then inside this loop, we use for C like column from the first column to the third column, step 1. And then we say read an integer and store it in the matrix. Let's name as M in the row R, column C. And this is everything. So we need to N 4 and N the other 4. We are going to select the largest number of the 2 by 3 matrix. So we need again to see all the data of the matrix. As we are going to select the largest number, we begin with this variable. Ln means largest number. This is the name. Of course, you can use another name, but let's use this name. Ln is largest number is equal to O. As we are going to find the largest number, we begin with O. You will probably find every number is greater than Ln or greater than O. Okay? Then for R equal from 1 to the second column, second row, step 1. Remember, we have to see all the positions in the matrix. Then for C by column is 1, 2, 3, step 1. Then let's ask if M is the matrix, row R, column C is greater than Ln, that means the largest number is Ln equal to M in row R, column C. And if N4 and N4. Okay? Now let's see. With this process, or with this step number 2, we can find the largest number, the greater number in the matrix. But this is not the question. The question is the position where this largest number is located in the matrix. So now we are going to show that. Then we have to see every position in the matrix. So we have to see every position in the matrix. Then for R from the first position or the first row to the second row with a step of 1. Then for column equal from the first position to the third column with a step of 1. And let's ask if M, the matrix, position RC is equal to Ln, that means the largest number is in this position. So we only have to write R and C. Okay? This is the position. And if N4 and N4. And the output is the position or positions of the largest number of the 2 by 3 matrix. Probably you ask, why positions of the largest number and not one position, a single position? Because the largest number could be in many positions of the matrix. Okay? Probably repeated. So let's see the call test. Remember, for the call test, we need space for the RAM memory and for the display. This time we need a matrix. We call it M. This matrix is a 2 by 3 matrix. That means it has row 1 and row 2. And it has column 1, column 2, and column 3. This is a 2 by 3 matrix. And also we have some variables, R for the rows and C for the columns. These are the names I chose. You can choose any other name. Okay? So I'm going to copy the first step, only because I think it is very easy for you to understand this concept. This is the step number 1. Load the matrix 2 by 3, the 2 by 3 matrix. For R equal to 1, it finishes in 2. Step 1. And column is equal to 1, it finishes in 3. Step 1. You can find instruction, read M is a matrix RC. That means read a number and store it in the matrix in the row R, column C. Suppose you receive, or the computer receives, number 4. Number 4, in the row 1, column 1. So number 4 is coming here. N4, so it's going to increase C, step 1. 1 plus 1 is 2. Now read a number and store it in the matrix. The row R, column C. That means row 1, column 2. Suppose the computer receives number 6. this number is coming to the row 1, column 2. That is 6. Now increase column in 1. Now you read another number. Read MRC. That means read the number and store it in matrix row R, column C. Suppose you receive number 3. This 3 is coming here. Why? Because this is row 1, column 3. Okay, N4 and N4 again, because C is in 3. You can see this loop is from 1 to 3. Okay? Now step 1 to the row 2. And column is coming again to 1. Read a number and store it in matrix row R, column C. Suppose you receive number 5. Okay? This 5 is coming to the row 2, column 1. Step 1, that means column is 2. Now read a number and store it in the matrix row R, column C. Suppose you receive number 4 again. So this number 4 is coming here. Why? Because this is the row 2, column 2. And 4, so step 1. Read a number and store it in the matrix row R, column C. Suppose you receive a number 2. So this number 2 is coming here to the row number 2, column number 3. Right? Okay. Step number 1 is finished. So we are going to check step number 2. Again, we are going to copy because I think it is very easy for you to understand this concept, right? So, okay. Now let's see. The second step, select the largest number of the 2 by 3 matrix. Let's see. Ln, another variable. It means largest number. Begins in O. So again, 4R equal to 1 from 1 to 2. And then C equal from 1 to 3. The question, if matrix M, row R, column C, that means this 4, this is the row 1, column 1, is greater than Ln, the answer is true. So Ln is equal to matrix row 1, column 1. And if N4, so increase C in 1, that is 2. Again, if matrix M, row R, column C is greater than Ln, that means 6, this is the matrix row 1, column 2, is greater than 4, that is true. So Ln, the variable largest number, is equal to matrix row 1, column 2. So 6 here. And if N4, that means column plus 1 is 3. Now let's see. If matrix row R, column C. That means row 1, column 3 is greater than ln, 3 is greater than 6. That is not true. So, and if n4, n4 again, so we increase R in 1 and column back to 1. The question, if matrix M, row R, column C is greater than Ln, that means this is number 5. This is the row 2, column 1 is greater than 6, that is false. So, and if N4 increase column C or variable C, as if matrix M, row R, column C, that means this 4 because it's located in row 2, column 2. 4 is greater than 6, that is false. So, and if N4 increase C in 1, so C is equal to 3. Now ask if matrix M, row R, column C, that means this number 2 is greater than variable Ln, that is false. So, and if N4 and N4. Now, we're going to the third step. R begins in 1 and C begins in 1. Ask if matrix M, row R, column C is 4 is equal to Ln, that is false. So, and if N4 increase C, again ask if matrix M, row R, column C is number 6 is equal to Ln 6, yes. So, write R is 1 and write 2, that is C. Write R and C, that means write 1 and 2. Okay? And if N4, so increase C in 1. That means C stores 3. Now ask if matrix M, row 1, column 3, that means this number 3 is equal to this 6 is false. So, and if N4 and N4, because the top of this C is 3, so increase R in 1, that means 2, and again C is coming to 1, back to 1. Ask if matrix M, row R, column C, that means this number, is equal to variable Ln, false. So, and if N4 increase C in 1. Now, ask if matrix M, row R, column C, that means this number 4, is equal to Ln, that is false. So, and if N4 increase C in 1, that means C stores 3. Ask again if matrix M, row R, column C is equal to Ln, that means 2 is equal to 6, that is false. So, and if N4 and N4, because the top of R is 2 and the top of C is 3. And this is the last part, last step of this algorithm. So let's see what do you have here in the display. You have six numbers organized in rows and columns, equivalent to the memory. You have two rows and three columns. And you have the position where you can see the largest number of these six numbers. Of course, this number 6 is located in the row number 1 and in the column number 2. Did you reach the target? Yes, of course, you reached the target.